on page 34, doing lesson 9. Points, lines, rays, and line segments. We're going to look at angles, and we're going to look at perimeter, okay? So let's all open in our book, please, to page 34. And let's start here. We show a series of dots, each one smaller than the one to its left, right? You guys can see that. If we continue drawing dots with each one smaller than the one to its left, we would finally have a dot so small that it could not be seen without magnification. Okay? This dot would still be larger than a mathematical point because a mathematical point is so small that it has no size at all. A point is an exact location in space. We represent points with dots and usually name them with uppercase letters. Okay, so you guys have been doing your number line, and you understand, come on, put that in your pencil and quit playing with it. Understand that on your number line, you have to draw a dot big enough for me to see it, right, in order for me to give you credit for that. But in math, theoretically speaking, mathematically speaking, that dot only represents a tiny little piece. A is just a tiny little spot in space, okay? And B and M on our number line at the top of 35, okay? So, a curve. Will someone read us that paragraph, please? A curve is an endless connection. Make it go for it. Top of the next page. A curve is an endless connection. Page 35, Jarvis.
All curves is an endless connection of mathematical points. A line is a straight curve because a line is made of mathematical points. A line has no width. However, a line does have one dimension. Length, when we draw a line with a pencil, the line we draw is a graph of the mathematical line and line. The location of the mathematical line. We sometimes put arrows in the ends of the line to the side that the line continues by in both directions.
Good. So we make sure we've got our arrowheads. It means the line continues on in both directions. We understand that line. You got to draw it for me to see it. But again, that's a very small, just showing you in space where that one-dimensional line is. Okay? Any 2 points? Jarvis, pick us up. Any 2 points?
Any 2 points
Make that.
any 2 points on the line can be used to name a line. We use a oval bar with 2 arrowheads and
To indicate
a line. Any of the following
notations.
notations beside the line or
Designate.
designate the line shown above.
Good. So we're learning how to name a line. We can name that line AB with arrowheads and our bar over it. You can call it BA, you can call it MA, you can call it AM, BM, MB. Any combination, as long as you name from one point to another on the same line. Okay? Give it arrowheads over top. Alright? These notations are read as line AB, line BA, and so on. Okay? And all the notations name the same line. We all understand that one? I think you guys are good. A ray is sometimes called a half line. What makes a ray a half line? Looking at that picture in the middle of the page, PQX. What makes that ray a half line? Jarvis?
Because we got a point that shows the ending point and arrow to show the continuation.
Perfect. Exactly right. So it only has an arrowhead on one end, and we know it stops at point P. It does not continue on forever past P. It only continues on forever past X, away from P towards X. Okay? So we can put a line with an arrowhead on one side to name a ray. Okay? We go one step further, and we get a line segment. How is a line segment different than a ray or a line? Jarvis?
They got 2 ending points.
2 ending points, exactly. So it gets its name, right? A segment is a little piece of something. Okay? Okay? A segment, okay, we've got no arrowheads on either end because you know where it stops and you know where it starts. Okay? Beautiful. So, when you've got line segments, if you look at the bottom of that page, alright, if you know, it's giving us the line segment A, B, C. And we can name it in a variety of ways. Someone name me this line segment. Jarvis?
Line segment AB, line segment BC.
Beautiful. And you can also rearrange these numbers. They can go either direction. Doesn't matter which one you list first. Okay? Good. So, we've named our line segment. That was just some extra practice. Good job. Alright, and now we can apply it. You know what a line segment is, and you know that if you take AB and you add it to BC, you get the whole thing, right? This piece, add it to the big piece, you get the whole thing, okay? So if you're told that AB is 3 units, this little part is 3 units, and this part, it tells us it's 7 units. Oops, sorry. We don't know that one. This one, I did. I misspoke. It tells us AC is 7 units. Find BC. So if we know the whole thing is 7, we know a piece is 3. What's the other piece going to be?
4.
Use some hands. Travis? 4. 4 units, right? Make sure you give it your label, okay? So BC is 4 units. Perfect. 3 plus 4, the other piece, gives us the whole of 7. Okay? So let's turn our page. We're at the top of 36. And it brings us to our next section about angles. Okay, we've got 4 different kinds of angles. And I'm pretty sure that you guys have all seen these before. So, Jamaica, give me one kind of angle and tell me a little bit about it. One of the 4 that we're talking about today. What's an angle? What kind of an angle? So, an acute. Give me just one. You said acute first, so let's talk about an acute angle. How would I draw an acute angle? What is an acute angle?
It looks like when you open your mouth.
When I open my mouth, which means I can't open very far right now, right?
Yeah.
Okay? So, it's cute. I like to think, the way I remember acute is it's little. You call things that are little cute, right? Little puppies are cute. Little kitties are cute. You might not think so. I think so. And little angles are cute, right? So an acute angle. And what is the mathematical definition, of an acute angle, Jamaica? You said it's little. How little does it have to be, Jamaica? Less than 90. Exactly. Less than 90. Portia, you want to give me the next one?
I want some tissue.
I don't have any tissue.
It's on my side.
I don't have any tissue. Okay, so we got acute, less than 90. Somebody else tell me about another kind. Jarvis? Which one do you want to tell me about? A right angle. Okay, so how do I draw a right angle?
Straight up.
Straight up. Beautiful. And I give it a little box in the corner, right? Because that shows 90 degrees. Exactly. So 90 degrees, it has to be perfectly 90 or just right about 90? Perfectly 90. To be a right angle, it has to be perfectly 90. Beautiful. So we've got our right angle. We've got our acute angle. Give me another one. Somebody else. One of the 3 in the middle here. Give me a hand and give me an angle. Portia? Obtuse angle. So how do I want to draw an obtuse angle? I'm asking Portia only. Portia, how do we draw an obtuse angle? Where do you want my ray to come off of it?
It's gonna be
It's gonna be big? How big?
Yeah. 180.
Exactly 180?
That's a straight.
Oh, what's the other thing called?
Greater than 90?
Yeah.
Okay, greater than 90, but less than what?
180.
Beautiful. So it's got to be more than our 90 degree angle with the square over here, right? So this needs to be more than 90. For Shay, less than 90, but more than 90, but less than what?
180.
Less than 180. Thank you. Jamaica, don't confuse us. Less than 180. Right? Don't forget our degrees. Okay, and last but not least, Damon or Destiny. Let's take the last one. Come on, go for it. What's the last kind? Straight angle. Good. How do I draw a straight angle, Damon? Give me words. Straight across. Okay, so there's our straight angle. And what is a straight angle, Damon? 180. What? 180. 180 degrees. Good job, Tamika. Okay? City of Refuge Kitchen is our 180 degrees, right? 180 degrees. Don't forget your little degree sign. So we've got our straight angle, our right angle, our acute angle, and our obtuse angle. obtuse, kind of, yes sir,
How many times, how long until we go to?
a little while.
You got another
Okay?
question?
Obtuse, more than 90, or more than 180, sorry, more than 90, less than 180. Obtuse, if we kind of think it's got the same beginning as we talk about in America, we've got a lot of obese people, right? They're a whole lot bigger than they need to be. So, obtuse is big, okay? Acute, cute and small, obtuse, big, okay? Beautiful. And last but not least, we come to our perimeter, okay? So the perimeter of a building. How would we figure out what the perimeter of a building is? Jarvis?
We multiply all of the sides.
Okay, be careful. Perimeter. How would we figure out the perimeter of this building? Add up all the sides. How are we going to figure out for the perimeter, right? The way I think about it is you can walk around it, right? How far would you have to walk around this building? That's the perimeter of the building, right? 285, the interstate, you guys know your map, right? 285 is the perimeter of Atlanta. They call that the loop, right? Shows you the perimeter of the city, goes around it, okay? So if you drive the perimeter, I think it's 62 or 61, 63 miles around the city of Atlanta, you're driving the perimeter. 1 hour, if you're going 60 miles an hour. Okay? So, the perimeter, the distance around. If you were to start at one point and walk around something, that's how you can figure it out. So, Damon told us, you count up the sides, you figure out the length of each of the sides, and you add them together. Okay? So, for our first example, in this section, we're on example 9.2. Find the perimeter of this figure and dimensions are in meters. So what are we going to do to find the perimeter of that figure? Destiny, why don't you give us this one? How are you going to find the perimeter of example 9.2? Add what? All the numbers. What are those numbers?
17, 18, 19, 20, 21.
Beautiful. So she named them all. When we add them up, what do you get, Destiny? 64 meters. Don't forget to label. Good. 64 meters, okay? For example 9.3, you're not given all of the information, okay? You're not given all the information, but with what you know, can you figure it out? For example 9.3 at the top of the next page, okay? We have a picture. It's got a big tower sticking up on one side and another tower sticking up on the other side. And my pictures are never going to be quite to scale, but you guys can get the hint. Or get the gist of it, okay? 4, 14, 8, and 2. Okay? So, based on what you know, what can we figure out, Jarvis?
It matched the other side.
Which one?
The
tower?
Yeah.
Okay, good. We know that the 6 is the same height. We're told 8 on this side and 8 on this side. So we know that these two are exactly the same height, which means that this one has to be 6.
Yeah.
Perfect. Okay, how are we going to figure out this one? Destiny?
Since we know that the bottom is 14 and the something feels like the top of 6 altogether,
Exactly.
subtract 14.
And you get 8. Good. So we can figure out this one's 8 and this one's 6. Okay? If we look at it, we can always look at horizontal lines. Look at anything horizontal. Okay? So it's like the line segment. That's why we learned about that right now also. We know the bottom is 14. You know a piece of the top is 4, and another piece of the top is 2. So what's left? She told us 8. 4 plus 8 plus 2 gives us 14. Okay? We all understand that? So, now if we do the perimeter, what is the perimeter? Jamaica, what's the perimeter going to be for this one? How am I going to find it? Add up both sides. What am I going to add? 8 plus 16 plus, where did the 28 come from? 14. Okay, so she's taking care of this one and these 3 together. So we've got 16 and 28. What else are you going to need to add to it? You took care of all the ones that got slashed. That's one way you can do it. So what else do you need to add to this? What's missing? The 6 and beautiful. So 12. If you want to combine it like that and then add it up together, that is completely fine with me. So Jamaica, do the math for me real quick. Beautiful. So 56, and it gave us the units as feet. So my answer, 56 feet. Okay? Make sure you give it back its label. Okay? Beautiful. So you guys figured it out. We're at our practice. You've got A, B, turn page, C, and D for practice. Okay?
What?
You can do it. A, B, C, D. 2 practices on page 37, and 2 practices on page 38.